Hi, everybody. My name is Fraser Cain, and I am the publisher of Universe Today. But also, now I am the moderator, the administrator of the Google Plus space community here, which is the newly added feature to Google Plus, which is the communities. And so, of course, we wanted to get on and make a community just for space and astronomy and photography, space photography, and videos, and so on. And so we've got that going. And so now I think we'll be adding the virtual star party to part of this space community. So now we've got really bad weather across all of our observing areas. So we've got one telescope tonight. So we're going to be probably looking at a lot of pictures while Gary keeps up with the observing part. So this will be more of a little bit more talking, a little bit more science, less oohing and awing at pretty pictures. Although Gary is going to deliver some pretty pictures. So, joining us this week, we've got our good friend Gary Gonella. Hey, Gary.
Hi, guys.
And thanks again for setting off your weather machine that cleared out the sky above your house in Los Angeles. We really appreciate that.
Still not the best seeing, but I can see stuff.
We saw the pictures you already displayed, and they were great, so I think we'll be all right. We've got my Astronomy Cast partner in crime, Dr. Pamela Gay. Hey, Pamela.
Hey.
With a cool new little logo there with your little boot, and you got the Cosmic Quest colors going on. That's awesome. We've got Cosmic Ray Sanders, who's going to be running the Stellarium show tonight. Can you give us a preview of that, Ray? Can you do that?
Absolutely.
There we go.
So there we go. Looking east towards Orion and Jupiter. So, and we can move this around depending on where Gary is pointing his telescope or where everybody decides that they'd like a little peek at the night sky.
Perfect. And so what we'll try to do is give people some context of the of what constellations the various objects we're looking at, and try and help people, if they so choose, go out and find these objects on their own. So hopefully you'll learn something while we do this. Scott Lewis.
Hi, everyone.
Who's survived his Movember and was able to clean up again.
That's right. I am shaved once more.
We deeply appreciate our fuzzy Scott, though.
I felt so good. I don't have an itchy face. I like not having an itchy face.
And then, of course, we've got Dr. Thad Szabo, who is now a new big piece of news, Thad.
Oh, I've got tenure 2 weeks ago at Cerritos College, so they're stuck with me. Ha!
No, they love you so much that they want to keep you on and let you do research with them. So that's fantastic.
It's very good, and I know that they are also going to be getting some new equipment, like finally a mount that works for our 14-inch. So maybe I'll actually be able to do some of these from there with our our Schmidt-cast. So.
That's great.
So.
I'm going to mute you, Ray, because I'm getting some background noises. Okay, so for anyone who has never done this, and I suspect there might be a lot of new people this week, so I'm going to sort of take it back to the basics. So what this is that this is a live view of the night sky. So right now we've just got Gary, although some other astronomers might join in a little bit later, and Gary is broadcasting a live view from his observatory in Los Angeles of the night sky, just as he sees it. And we're going to move from object to object, and we're going to sort of explain what it is that we're looking at. We'll take requests. We'll be happy to take any requests from people if there's some object that they want to see. And we'll explain. We've got 2 PhDs here, PhD astronomers, so we'll be able to explain the sort of the science behind what it is that we're looking at. And so we'll just sort of move through the night and take about an hour and sort of see what's up. Now, if you want to make any comments or requests, or you want to make any questions or anything, there's a bunch of places that you can do that. If you're watching this on YouTube, you can make a comment in the YouTube channel. If you're watching this over on the event page on Google+, you can post a comment there. If you're watching this on trying to think where else. If you're watching this just somewhere embedded, like on our Cosmic Quest page, you can just use the hashtag on Twitter which is Virtual Star Party, or no, Star Party. We use the hashtag Star Party, don't we?
Right, Star Party.
Right, and then if you're watching this just on Google Plus in my stream, you can make a comment there, and we'll be able to see all of those comments. Now that said, there's a lot of places where this can happen, and so what we always recommend is that if you really want to chat with us, make your way to the YouTube page if you can, because that seems to work the best, and we're able to pull in those comments quite quickly. So if it seems like we're ignoring your comments or questions or requests, it might just be that we're just not seeing them, but we definitely see them when they're done on YouTube. So.
And you can help raise the quality of comments on YouTube.
That's
so
true.
Be part of community change.
That would not be hard. Yeah.
Let's raise everything up together.
Yeah, and so if you haven't already, take a second and join the space community on Google Plus, which is this newly added feature, and you can just click on the Communities tab, and then click on you can do a search for space. And then you can join the community. And right now we have about 15,000 people who are in the community. So this is crazy. Welcome to everybody. And hopefully we'll keep you entertained and give you a chance to really explore the night sky. So let's get rolling.
Real quick, before we get started though, this is an exciting time through all of Google+. The 12th month of 2012 is been dubbed December, so we are actually going along and spreading the good word of all the STEM fields, which is science, technology, engineering, and mathematics. We've teamed up with Google Science Fair and Girl Start, which is this fantastic group out of Austin, Texas, that goes and puts a lot of effort into bringing girls in the K-12 environment and getting them interested into the STEM fields. So throughout this entire month, we've been having hangouts with some biologists, like Erin the other day with her research with Diana monkeys. We've had a hangout with CERN, Nat Geo. Peter and I the other night did a live observation of the transit of an exoplanet. So there's going to be hangouts all month long, just trying to get everyone involved, engaged, and excited about the STEM fields. And this one tonight will be no different. So anyone out there that's interested in STEM, stay tuned. Use the hashtag DSTEMber throughout all of Google+, and you'll be able to find all sorts of different activities going on.
Fantastic. Oh, someone should probably share it into the space community, the live video.
I already did.
Oh, did you already do that? Okay,
I'm on this.
All right. And then I think, I see it, yeah. And then I'm just going to ban that. No.
Wow.
I know. We run a tight ship, Scott. We're not good enough.
I know.
Some self-loathing here. Okay, so let's just start with this beautiful image of some kind of bright ball with a cloud around it. Gary Gonella, what in space are we looking at?
That is the great galaxy Andromeda. That's a 2-minute exposure. And I'll let the rest of the people who know what they're talking about describe it.
Right.
Okay. So the nucleus of the galaxy is the bright center there. So this is the densest part of the stars that are in the galaxy. You can see a few dust lanes. So a galaxy is essentially only 3% of the mass is typically made of stars. About 12 to 15% of the mass is gas and dust, and then the other 85% is dark matter. I hate that name. If I could do anything in my astronomy career, I would change it to invisible matter. That is more appropriate. Dark is like, this shirt doesn't reflect light very well. This is a dark shirt. It's not an invisible shirt. Well, that would be another kind of hangout then, wouldn't it?
Some kind of framework, right, that people put all of their crazy ideas on. Like, I don't know what it is about the dark matter and dark energy, but we were having this argument actually in the space community, and someone just said, like, they're not real because I don't like the names.
Yeah. There's lots of things I don't like the name of, and they're still real. Heck, I don't even like my own last name most days, and it's still real.
Still real, yeah. Someone gave it to you. So now, do we have a bright core in our own Milky Way galaxy like the one in Andromeda? Can we see it?
Yes. Look at Sagittarius.
But it doesn't seem as bright in the same way. Like, if you go out and you can actually see the Milky Way, you don't see sort of this bright core in the same way, though, right?
The problem is we're on top of it. So sometimes when you get too close to something, you can't notice all of it as well as you can when you're far, far away. When you're right up in the foothills of a mountain, it may not seem quite as large as it does when you can see it compared to all the mountains around it. With our own Milky Way's nucleus, if you do a photographic panorama to capture the entire Milky Way disk, you will see that it bulges out as you get through the constellation Sagittarius. But if you just look at Sagittarius, you don't have the perspective with which to see that it is that much bigger.
And I can see these two additional bright objects in the image there.
Yep, the one off to the upper left there, that's M110, which is a dwarf elliptical galaxy that's orbiting the Andromeda Galaxy, which is M31. And then there's that small blob off to the right, that's M32, another dwarf elliptical. So just like you can have a large spiral like Andromeda, and Andromeda is actually a larger spiral than our own Milky Way.
Yeah.
You can have these smaller galaxies that orbit it. Like, for instance, if we had any southern hemisphere astronomers, they could possibly give us some views of the large and small Magellanic Clouds, which are the galaxies that orbit our own Milky Way. So. And also, just to add something that Pamela was talking about, I mean, one, the perspective thing is the large part of it here. That, you know, when you look at Sagittarius, I mean, it takes up this significant chunk of sky, and it's really hard to say, okay, does the Milky Way get wider and brighter there? In fact, I mean, most people in, say, populated countries can't even see it anymore because of light pollution. But the other thing that's going on is there's so much gas and dust in our galaxy. It's really difficult to see stars beyond about 3,000 or 4,000 light years. Even telescopically, I mean, William Herschel, when he was coming up with his model for the galaxy, it kind of cut off at about that distance, even with the telescopes he had available, because there is so much attenuation of light due to all of this extra material in the galaxy.
Well, let's move it.
Yeah, just go get a leaf blower, right?
Well, we can actually remove it if we go to longer wavelengths. Yeah. That's the awesome thing, is when we look at our own galaxy in the infrared and longer, we're suddenly able to peer through all of this gas and dust. And so when we're trying to observe stars orbiting the black hole in the center of the Milky Way, we're actually observing all of that going on in longer wavelengths that are able to penetrate the gas and dust. Now, on the other side, if we want to see Andromeda suddenly get 3 times bigger, we can also look at it in the infrared, and all of this cool gas pops out that we're able to see in those wavelengths. It all depends on how infrared we get.
Yeah, Ray's dug up this great image of the Milky Way in infrared, and you can see that core right there in the middle, and then you can see these spiral arms, but they were seeing it from embedded within it.
Yeah, and to kind of actually plug CosmoQuest a little bit, we're currently in the middle of a Galaxies and Galaxy Clusters course, so some of the teaching aids that I've been using to illustrate galaxies also talk about the point that Pamela was bringing up, in that we can look at galaxies in different wavelengths and see different things, radio and infrared being really good to see through all the dust. And just like you were saying, Fraser, you can see that central core of the Milky Way. And also, notably, if you look down about halfway down and over to the right, you can see 2 little smudges. And of interest, that's the small and large Magellanic Cloud, little satellite galaxies that are visible in the southern hemisphere.
Yeah, those lucky southern hemisphere. I wish I could see them.
We will be able to see them soon. If my estimates are correct with how we're doing everything, probably within a month and a half, we will have a separate virtual star party to this one, focusing on Southern Hemisphere and all of our awesome people on the other side of the globe. So we will be able to see. We won't be just selfish, North Americans. We will spread the love and get to see the amazing things that are going on in the Southern Hemisphere.
Now we're gonna go to this next object that Gary's dug up, but before we do, there's a great question from Guilherme Lessa on YouTube, and saying, since this is the Gemini week, I'd like to ask why some meteor showers have greenish meteors like the Leonids, and others have orange-reddish colors. So why do we get different colors from the meteor showers?
Composition of what's hitting the atmosphere and self-destructing, and also the energy released. So it's a combination of burn color and temperature of what's getting ionized in the upper atmosphere.
like, I don't know if you ever used to do this. We used to, like, when we had like a fire in the house, like in our fireplace, we'd throw different in the house. When we lit our house on fire,
I've tried that. I don't recommend it.
No, but we had a fireplace. And you put different kinds of, like, we take like those catalogs, like Sears catalogs, and you throw in the shiny paper, and you get different composition of the color of the flames because what the paper was sort of coated with.
Well, and that's part of
got poisoned. Now that I think about it,
right? And you put my old profession.
That's part of the basic. That's part of the basic chemistry of making fireworks. Is that you can throw things in like magnesium or copper or iron. You throw those different metals in with the powder, and when it detonates, you can get the beautiful green, the reds, the blues, the bright white. Flares of those miniature and such.
Yeah. Okay, so I've got one more question here. This comes from Corey Wilder. I'm assuming they're also amateur radio astronomers. Would there be any way to incorporate them into the on-air hangout? Have you talked to Nicole about some way to incorporate a radio astronomy into this?
Yeah, so the real issue is normally when you take an image with a radio dish, the way you take the image is you either scan your radio telescope back and forth across the sky and you build the image up while you scan, or you do individual footprints and build up your image from those. If you simply point a radio telescope at the sky, you get back signal or no signal, and that's not interesting for the hangout. So we're working on this one.
Yeah.
But there is no headphones involved with that. Just so everyone knows, radio astronomy is not.
It's not listening to the space for
radios. When we're talking radio, we're talking about a longer wavelength of light that we can't see. That's all radio is.
All right. Well, let's get to this amazing image. So, Gary, what are we looking at now?
This is NGC 7380, which is called the Wizard Nebula.
Oh, so this is where we have to use our... I don't know, Ray, if you can dig up some more wizards, we have to sort of figure out...
I see a My Little Pony.
It's great. Everyone's turning their...
I'm trying to see the
I'm actually trying to bring that up in Stellarium, and it's kind of like, what?
Yeah.
I gotcha.
It's the hipster galaxy is what it is. It was cool before everyone knew about it.
What is it?
It's a nebula.
Yeah,
thank you, Pamela.
It's an emission nebula.
Well, it was discovered by Herschel in 1787, and it's technically an open cluster, but it's obviously a nebula in there as well. And it's really pretty, especially if we can get it in color. Let me see if I can snag an image of it and screen share it.
And for those who want to find it in the night sky, it's in the constellation of Cepheus, which, despite it looking like a house, is actually named after a king, because supposedly it looks like a throne and not a house. So that's what we've got on.
But like, what kind of, like, when you say that it's an emission nebula, I mean, is that like going to be like some star is giving off that? Whoa, there's a good picture of it.
Okay.
So the way emission nebulae work is the light that's entering the gas, dust, stuff, ends up triggering it to emit light. So you have reflection nebula, and this also has elements of reflection nebula to it, where you get scattered light coming out, and then emission nebulae is literally it's emitting light that it's absorbed and re-emitting.
And so you can see the we lost Scott's image there, but you can see.
I thought I was prettier, but okay.
but like this image, this photograph, I mean, this has been the color one. This is something that someone might have taken several nights to produce an image of this depth and this sensitivity, right? Compared to what Gary did in a 2-minute exposure.
Yeah, 2 minute. And for new people, I am taking my pictures in the light of hydrogen alpha, very, very narrow red color. And that's what hydrogen glows at.
Right.
And so, go ahead.
So So for the picture that Scott had up there, the reddish brown. I know you keep coming back, but really, we just want
Okay.
This
is a gorgeous image.
It is.
I will.
Yeah.
You'll get your FaceTime. It's okay. what we got here, the kind of reddish, orangish areas, that's mainly the emission nebula region that that Gary has imaged here. And so you also see these kind of dark clouds in front. Those are much cooler regions. And the blue that's presented here is the reflection nebula. And reflection, probably scattered light, scattering nebula, maybe? I mean, and essentially any nebula is scattering the light that comes into it. But the blue is light that's not really causing the electrons to jump levels like it is with hydrogen alpha. It's just that shorter wavelengths get scattered out, and blue is shorter than red, so it appears bluish. Much the same way the sky here on Earth appears blue.
You don't look bluish.
So
Yeah. I got a couple of questions we'll deal with. So, Gary, I don't know if you've got another image ready to go.
Yeah.
Okay, so this one comes from Marco Labor. How would you like to have a telescope viewing the auroras from Sweden? We would love that.
Yeah.
Yes.
I've actually been thinking about like what would it take to actually get some kind of imagery so we could see some auroras from a region like that. So if anyone, so yeah, absolutely. By all means, drop me an email or drop Scott an email, and we'll try and get you connected into the system. We'll do some tests because getting some live auroras would be like we would just do a separate aurora view and do a show about that.
Yeah.
So absolutely. Steve Martinez wants to know: can we discuss the equipment that we're using to capture the images? He's got a 10-inch Dobsonian with a lifetime webcam. Could that be used?
With
So,
a what
Gary,
webcam?
With a LifeCam webcam?
I've got a LifeCam. Mine's a Microsoft LifeCam Studio Pro, and it works fairly well.
Connected to a telescope?
Yeah, that's what I've used for the eclipse and the Venus transit.
Okay.
with a Dobsonian, he might not have tracking, but that doesn't mean that it couldn't be used. I mean, you can always, like for something like the moon or the planets, just kind of move the telescope along with the object. The other thing is just recording a movie of the moon or planets and then using stacking software like AutoStackert or let's see, Registax, and then going ahead and putting together one image from all the images in the movie.
I mean, right. So with a 10-inch Dobsonian, you're going to get a really nice amount of light gathering. You're just not going to get that tracking unless you're like Corey Schmitz and you create your own home-built tracking system.
Well, and the other thing is too, Fraser, with the different amounts of focus required, sometimes with different webcams, you have to play around with different extender tubes, and sometimes you have to use longer ones and sometimes shorter ones. But generally speaking, with a little bit of work, and chances are if somebody's smart enough to use a telescope and hook up a webcam to their computer, they can probably figure out excuse me, they can probably figure out the amount of in focus or back focus that they need to make everything focus right with their webcam.
And going the DSLR route, like a Canon, you can get like an old Canon Rebel, like a T1, for a couple $100, even like $100 used on.
Well, even the T3Is like we have are starting to come down in price.
Yeah, they're like body only for like $300. I've seen T2s for $250. So, and they produce a beautiful color CCD that you can bolt right into the you can get a ring that allows you to mount it right onto your telescope, and then you'll just get really wonderful views. So if you've already got that 10-inch Dobsonian, to get that extra investment of a DSLR like a Canon T2, it will be great. And you don't need all that like live HD video and stuff. So just a T2 would be great. This is Gary's telescope here.
Yep. Anybody cares? This is a live video from my pod. So
and his pod is awesome. It is so cool.
And full of stars.
Yes.
Yes.
Alan Curlin wants to know what happened to the folks from Denmark who were here last week. Jens Rigelsen. They are rained out. So they were going to try to join us, but they're rained out. So no. And I guess one last question here is: do LPR filters significantly help to remove light pollution, and are they worth the money?
The one issue with LPR filters, and because I'm observing from a completely whited out area of Los Angeles, if you can't see the nebula anyway with your setup or with your telescope, the LPR filter is not going to make it show up. It can help cut down on the light and bring out some contrast if you can see it at all to begin with. So for things like where I am in LA, the Orion Nebula shows up a bit better with the LPR filter. Ring Nebula, Dumbbell Nebula, so things that I could see anyway. I can see more detail in with an LPR, but it's not like I can go pull out like faint detail in, say, the Swan or the Eagle Nebulas with it, because they don't even show up for where I am in Los Angeles. So they help with contrast, but it's not like, oh wow, I can suddenly see this when I couldn't see it before. No, it'll still be pretty much washed out.
Yeah. Okay.
Although, interestingly enough, though, we've talked about this before on some of the other virtual star parties, is that if you're in a dark enough site, you can actually take different filters and put them to your eyes and see different nebula that are ordinarily not visible or not very visible to the naked eye. So you can actually take like a hydrogen alpha filter and look around and, hey, wow, what's that? So
yeah,
but
and so that's
you're
what
right,
that's
Dad.
what Gary's working with right now, is this hydrogen alpha filter, and he lives in super light polluted Los Angeles, but he's able to see the stuff that gets through the light pollution because of this filter. And speaking of, Gary, what are we looking at?
Okay, this is the Propeller Nebula, one that I love. This is in Cygnus.
Yep.
Yes.
Mm-hmm. Yep.
And this whole area is, there's so much nebulosity in this area. All of this around here is glowing hydrogen. This is the outer arm of the Milky Way. Is that correct? We're looking out through the outer arm at this point, aren't we?
Let's see.
Cygnus?
I mean, kind of tangential. I mean, the opposite direction from the center would be more towards Orion or Monoceros or Gemini kind of region. So this is a little bit more tangential toward the to the galaxy. So from inside it, not because we're not exactly on the edge of the galaxy, so it's not a perfect tangent. It's more like, okay, so let's say this is the galaxy, right? Here's the center. This is kind of like looking off in this direction, not completely out. Right? I'm squishing your head. So
That's great. Now, what's causing this crazy propeller shape?
that's a good question.
The boat in front of it. And so it's a space boat.
It's heading away from us.
Yes.
Right. We're looking behind the space boat.
Well, they
But
said they
just
needed a bigger boat, and they found one.
Yeah, but so is it just a fluke? Focus, people. There's science getting done here. Yeah, is it just a fluke that it's got this shape?
Well, it depends on what's going on in the center. I mean, the one thing these kind of shapes would typically demonstrate in another system would be that gas is being sprayed out, and you maybe have two objects that are orbiting each other that would do it. I don't think that's the case here. I think this is too large for the curvature of it and the typical orbital mechanics of two objects that would be orbiting to produce this kind of shape. I think the idea of it being a fluke, and that it just happens to appear to us that the brightest glow has this kind of propeller shape. I mean, there's also this kind of little comma thing off to the left. It's not part of the propeller. So I think this is just a matter of perspective, of, where we are in the galaxy and getting a look at it. So, I mean, if it is a propeller, maybe it's breaking apart, and that's that piece flying off. You don't want to be in this boat. So.
What's kind of awesome is when I try Googling it to find out more, because this is an object I'm completely unfamiliar with, all I'm finding is these awesome astrophotography images and no science. So
yeah, I was in the same boat, Pamela. Boom.
Really?
Okay, so while Gary digs up another image, I've got another question here. So this comes from Suram Ravindran. What do astronomers actually learn when they look at deep images like the color image of the Wizard Nebula? What's the discussion you have with grad students? How do you interpret what you see? So I guess
you can do so much with them. I mean, at one level, you start going over them with the digital equivalent of a magnifying glass, looking for cocoons of star formation. You look at the structures, looking for shock waves. You look for jets. Different colors are indicative of different geometries of star versus cloud. There's an entire field called interstellar media, which is something I have never done, but there are entire careers dedicated to just trying to understand all of this nebulosity.
And this actually relates. There's a question from Brian Ross. What criteria is used to assign false color? Is it aesthetic or more geared towards contrast? I guess it depends, right? If it's if it's scientific, or if it's just being done for aesthetic purposes, right? Like Gary, when you pick your colors, how do you choose them?
Just aesthetics. Just for the aesthetics. How it looks best.
So you throw out all the science and you just look for whatever looks best.
Yeah, absolutely. That's why I do it.
Yeah.
I threw this up real quick so you can see when we talk about the filter I have, this is your whole visible spectrum down here. And you can see it just passes this little bit right there where hydrogen glows.
Yeah. So when you think about the entire spectrum that we could be looking at, like what your eyes look at, with the images that Gary is showing, they're just in that little red spectrum.
Just a couple other things Ray wanted to mention. He is Stellarium up right now, but he wants to mention that you can look at rotation curves, and you can look at redshift to see the motion of objects inside of a nebula. Well, not so much a nebula, but more the stars within it. To see, are they part of this cluster? Is the cluster, are the objects moving slowly enough that they're held together by gravity? Is it kind of flying apart? So that's some other possibilities. And on the topic of coloration of images, there's something called the Hubble palette. And so a lot of the images that you get from Hubble, they'll use colors to specify what elements are present. So they'll typically color hydrogen green, which is not how it would show up to the eye. I mean, if your eye could capture photons long enough to see hydrogen, it would appear red. But they use green to represent hydrogen, and I believe blue for oxygen, and I think it's red for sulfur, if I remember correctly, for the Hubble palette.
And that's the one I pick a lot too.
Yeah. Yeah, and so Gary will pick. He'll use his hydrogen alpha. He uses sulfur, and what was the other one that you used, Gary?
Oxygen.
Oxygen, right? And so that's 3 different filters, and they'll show 3 different views of the sky, and then he turns that into an image. He picks one to be red, one to be green, and one to be blue, and then that creates a color image. But it's not anything like what it would actually look like. It's just, it's showing the different colors coming through. So,
and that's a good point, Fraser, is that, a lot of people see the images coming off of the Hubble or Chandra or a lot of the other space-based observatories, and those are processed in different wavelengths. They've accentuated some types of features, honed in on a specific wavelength that's coming through and highlighted it. And a lot of the time it is really interesting to try and work with the public who see these images and then, translate that over to what we do in the virtual star party. And it's kind of like, okay, well, that's different. Well, for one, this isn't the Hubble. 2, this isn't the Chandra. We're not looking at X-rays.
Right.
3,
which would be awesome, though.
This isn't 2MASS. We don't have a big, liquid nitrogen-cooled, infrared telescope. Yeah. So that is one of the things that we do often have to, kind of work with and explain, hey, this is, this particular wavelength. So, yeah. By the way, Had, thanks for jumping in on that and helping what I was typing in on. For those who don't know, I've got a 1-year-old toddler, and we start the hangout about an hour and a half before her bedtime. So okay. Sometimes, right when it's getting close to her bedtime and it's the middle of the show, sometimes it's an experience, as anyone who has children will know.
So I want to get to this next image, but actually there's a great question that just came up from Eric Driscoll on Google+. So from a single perspective on Earth, what directions are the galaxies spinning in general? Is there a common direction?
Yeah.
And I know, Pamela, you went sort of through a big thing like this actually quite recently. So you want to just give a little bit of background on that?
So in general, one of the problems that we run into is trying to define, is there an overall rotation when you start looking at spirals, requires you to look at a large enough sample size that you can overcome any selection effects that you might have. A large chunk of space might have things that are co-rotating because they formed in a co-rotating chunk of space. Well, when you look across a large enough area, and in this case about 1/3 of the sky is what was looked at by the Sloan Digital Sky Survey, and you identify the rotation, either S-wise or Z-wise or edge-on, basically, of all the galaxies that you can see well enough to make that out, what you find once you correct for human brains is it is a complete random distribution. But the problem is that when in doubt, humans have a preferential way of looking at them. And I don't remember off the top of my head if we prefer S's or Z's, but when in doubt, we always guess about the same thing, which means that if you present a confusing galaxy, then reverse the confusing galaxy, we'll say it's the exact same thing, which is kind of awesome.
Yeah, but in general, the evidence seems to
random.
be there is no, it's a completely random distribution on which way they're
Once you
rotating.
look at a large enough chunk.
Right. Okay, great. So, Gary, what is this?
This is the Crescent Nebula. It's in the same area, general area, as the propeller. Again, it's an area of huge expanse of gas. Some of it glowing, some of it not glowing. Take it away, people who know.
Well, okay, so basically, this type of nebula, it's an emission nebula. And like Gary was saying, it's in the constellation of Cygnus. Basically, you've got stellar winds interacting with the gas and dust, and creating shock waves. They believe that this is about 500,000-ish years old, and Thad or Pamela might be able to go into a little more detail about the mechanics of stellar wind and X-ray emissions and what exactly a Wolf-Rayet star is.
So, yeah, the star at the center is one of these Wolf-Rayet, and it's French, right? Rayet? Is that it?
Rayet, yeah.
Okay. See,
Sorry,
I'm glad,
from Iowa. I pronounce things poorly.
I said Wolf-Rayet up until I heard Pamela say Wolf-Rayet a couple of weeks ago, and so I've corrected that. I was saying Betelgeuse up until I was 38 or 39 years old, and finally heard somebody go Betelgeuse. It's like, oh. Okay.
That has two allowed pronunciations, just like Uranus. There's so many pronunciations of that one.
But what's going on here with the Wolf-Rayet star is it's a very hot, very massive star, and so any star is a balancing act. You have the weight of all of the material on the outside that's pressing in on the middle. The more weight there is, the faster the fusion goes. However, the faster the fusion goes, that means the more pressure is pushing out from the inside, and so your most massive stars have a fusion rate that's so high it starts to blast the outer layers of the star off into space, that you get this very intense stream of particles coming off of them in all directions, and you can kind of see that here. It's not perfectly symmetric, but it looks like it's expanded away from something, and that's what's happened. This is extremely large hot star in the middle has blasted away its outer layers and is now providing enough energy to them to cause them to fluoresce. So this is our Crescent Nebula.
Now, is the Wolf-Rayet star that bright star that's right in the middle of the nebula? Or would it be like putting out so much material that it's actually like shrouded itself?
Oh no, you can usually see the suckers. I just don't know if that's it or not.
Yeah.
No, I was going to ask real quick, Gary, are you familiar with the Soap Bubble Nebula?
Oh, that one's cute.
The soap bubble. I'm not sure which one that is. I'm looking.
It's in the neighborhood, and the reason why I was mentioning it is because it's a similar phenomenon. And as a plug to the people out at Melt Wilson. But anyways, looking at that, I was just curious if you were familiar with that, because I know it's been imaged by a number of different astronomers since it's been kind of discovered and made known. It's near NGC 6888, so I'm not sure if that's something that you can pick up on at a later time, but figured I'd bring that to your attention.
Okay, I think I've looked for it once and didn't have any luck, but didn't spend a lot of time.
Now we've got a question, a little off topic. This comes from Richard Jameson, and so can someone discuss how to view the Geminids in Australia? And I think this is good because people will ask, like, how do I see this certain meteor shower in Portugal as opposed to in the United States? So, I mean, is there any kind of what's going to decide how you're going to be able to see a meteor shower? Does the whole Earth see them? What's going on?
No. Go ahead, Thad.
Yeah, it's really not terribly dependent on where you are. Essentially, find a good place where you have a good open view of the sky, and lie down and look up. No, really, it's pretty much that simple, because you want as broad a view of the sky as possible. The other thing is you want to look after midnight on the night of the peak, and this setup is pretty good for the Geminids this year because we're near new moon. So that means, I mean, the moon's not going to rise until very late in the night, very early in the morning, so you won't have moonlight interfering with the view of the Geminids. So just find a clear open space, maybe a lawn chair or something, and you generally want to face east. I guess if you're in Australia, I guess face northeast, but don't just focus on looking northeast. Especially another good thing, do this with a friend, right? Or do this with a group of people and have everybody kind of assigned to, okay, you're going to watch this portion of the sky, you're going to watch this portion of the sky, and then somebody, if a bright meteor comes into view, they go, ooh, and you turn to whoever's saying ooh,
Right.
and look in that direction.
But I guess
so
what I was driving at, though, is that there's no best... Let's see. So if there is a meteor shower like the Perseids or the Geminids, the Leonids, everybody on Earth is going to get a crack at it. You just want to look at it at midnight your time,
or
right?
later.
Or later, right?
Well,
right.
yeah. So the catch is midnight isn't what you want for this one. Maximum for meteor showers occurs when the Earth is plowing through this thickest part of the band of debris that was left by whatever is triggering the meteor shower. So it could be that we're going through that at sunset, and that's when you're going to get amazing bolids, exploding pieces that cast shadows in the twilight.
Right. But for one group of people, they're going to get that at midnight.
For one group of people, but everyone in the world who has some form of night wants to find out when is it going to be brightest. And also, you're going to end up seeing more when the part of the Earth that's hitting where that debris stream is what you're looking at. So with the Geminids, the majority, not all, but the majority of the meteors are going to streak away from the constellation Gemini, which luckily, since it's a zodiacal constellation, is visible to just about everyone, both northern and southern hemisphere. So if you are, unfortunately, though, on an extreme pole, it's going to be very difficult, and you'll see far fewer of these. Different meteor showers have different names, and they also have different centers. And so there are times when it's preferential to be in the southern hemisphere. There are times it's better to be in the northern. It's about improving the experience. You can go out any night of the year, anywhere in the world, and you will see meteors. But the number per minute that you see does fluctuate with place.
Well, and I think part of the other advice that's thrown around in like, website columns and newspapers and magazines and stuff, at least in my experience of, years and years and years of backyard astronomy, is a lot of the time they'll throw around the midnight to dawn time frame. Because generally speaking, it's when people turn their house lights off. It's when less people are driving. There's less ambient light, unless you're somewhere like, Los Angeles or New York. But generally speaking, almost everywhere I see that give guides to viewing meteor showers, they say go between midnight and, the pre-dawn hours.
Yeah.
Which really, in general, it's not a bad time to go looking. But, like Thad was saying, and in my experience and the experience of others, the general point to have a good meteor shower experience is to be comfortable, dress appropriate for the weather. If you're out in the middle of the desert, and me being in Arizona and taking people to meteor showers, they don't realize it gets damn cold in the middle of the night in the desert. We'll go from 110 degrees during the day down to 60 degrees at night, and there's people in tank tops and shorts. And then, of course, that's a whole other story right there with rattlesnakes. But anyways, to get back to the topic, bring comfortable chairs, like lawn chairs, and if it's cold, bring a thermos with some hot chocolate or some coffee and make yourself comfortable. Grab a bunch of people and just, hang out in a park, or, if you know somebody who lives out in a rural environment, camp in their yard, and, like Thad said, spread it around, look in like a 180, fan yourselves out in like a little crescent shape, and kind of pay attention and just have a good time. If you're, I've seen so many people who get to their first meteor shower and they're, I want to see one, I want to see one, I want to see one. And they're so pent up on seeing one that they'll miss like a dozen of them. And, just sit back, relax, and chill out, enjoy the night sky. And like Pamela was saying, you will see them. You can do that almost any night, just grab a lawn chair and look at the night sky, and you'll see at least a couple. Like people are always they're trying to optimize the experience, They're like, well, I only want to go if I'm going to see a certain number. But if you just head outside and look up, you'll see, during a meteor shower, you'll see some. And
It's fun, and so just go do it. All right, well, let's move on to this next object that Gary has posted for us, and we're probably going to go for about another 15 minutes or so, and then wrap things up. So, Gary, what are we looking at now?
This is a portion of the North American Nebula. This is what would be the Gulf of Mexico.
Right.
Florida's here, and Mexico would be down this way. So it's a huge area. I'll share this screen real quick here.
Yeah, I love your screen share of the entire thing with your field of view. It gives a lot of context.
Yeah, if I could find it. I got too many windows open.
While we're waiting this, Brian Ross. Oh, there was someone else asked this question. We'll get to Brian's question. Somebody said that we're going to go on a road trip. Oh, here we go. Corey Wilder says, what are your favorite open to the public observatories in the U.S.? I need a road trip. So are there observatories that regular folk can drive to and visit, and sort of even, do they have telescopes set up outside that people can participate
McDonald
in?
Observatory is one of the only ones that actually allows the public into their biggest domes. They offer once a month the opportunity to actually look through the 107-inch telescope. They allow amateurs to reserve once a month the 82-inch telescope. They do have a visitor center with a variety of telescopes as well.
Hey, I got to jump in and plug Lowell Observatory.
Yeah,
They're
that's
really
another
good
one.
about bringing people into the public and letting people use telescopes. There's also the Mount Lemmon Sky Center down in Tucson. They're really excellent about having telescopes set up and let people view. And like we were talking about earlier, although they don't quite let the public use the 60-inch and the 100-inch, but Mount Wilson Observatory, if you're near LA, that's a great place to go visit, even during the middle of the day. To just go tour around. It's beautiful up there, up in the woods.
Actually, you can get time on the 60-inch, not on 100-inch.
You can, but it's what is it, Scott? Like $2,000 for a night?
Last I heard, it was $750 for half a night for a group of 25 people. If you get a group of 25 people together, everybody pays $30. They'll provide you with an operator and half of the night on the 60-inch. So,
Wow.
I was with a group that had 1.5 nights on it back in June, Thad. So I forget what the prices were. I think you're right though about the half night being like $750 or $800.
That's a pretty unique event that you could organize with your friends and family.
Especially
so
when you split the cost, it's really
Yeah.
on such a historic piece of equipment.
Yeah, and so people in the comments are posting, apparently the Mauna Kea Visitor Center is good, Kitt Peak. So I wouldn't be surprised if almost every observatory is going to have some kind of public program, and just check their websites and then plot out your road trip. That sounds like a great road trip. I'm jealous.
It does.
Actually, another one in the LA area is I always mispronounce it because I think of Family Guy, so I want to say Griffin, but it's Griffith Observatory. That one has got a pretty good public outreach component to it as well.
Yeah,
so Gary, this is your field of view on the North American Nebula.
This is the purple box is what I see with my scope. So all of this is North America, and then this piece over here is called the Pelican Nebula. Now I will zoom out a little bit, and you'll see kind of where it is in the sky.
I love the phrase, everything is North America.
Yeah. Well, we're the only ones that exist, aren't we?
So what is the North American Nebula?
So it's another emission nebula, another region that's along the Milky Way here. So you're getting hydrogen gas, again, lit up by a very hot, young, massive star. It's providing energy to essentially knock the electrons out, and as they recombine with protons and drop down in energy, they emit light, and largely this reddish light through Gary's filter. It's only designed to see this reddish light, so basically just the intensity you get here shows how much light you're getting from hydrogen from each portion of the nebula here.
And why is it here? Like, why are we seeing this region all lit up? Is there something happening to it? Is there some kind of event going on, or is it?
So anytime you've got one of these, it's an O-class star, has to be nearby to provide enough ultraviolet light to ionize the hydrogen and actually knock electrons out. And as the negative electrons recombine with the positive protons, you get this reddish light that comes out as the electrons fall back down in energy and recombining with the protons.
So basically, there's a bunch of young stars around that are being hot and sassy, and in their youth, giving off vast amounts of high energy photons before they burn themselves out and explode.
Right.
Hot and sassy. Every time.
If you look up stellar classes, it's O and then little HS next to it. Yeah.
So are like some of those bright stars that we're seeing in the nebula, are those some of those stars, or could they be in front or behind?
A lot of what you'll see are going to be in front of or behind, but some of those will be the ones that are providing the power here. Yeah.
Right. And it takes a certain number of them to kind of get the whole a nebula of this size rolling.
A nebula of this size, yeah, but those stars are brilliantly hot. So many of the nebula that we see, it's just one of these that's doing all the work.
Wow.
Yeah, like for the crescent, it is just the Wolf Rayet. So yeah.
Now, are those bright stars? Are they actually pushing all of this cloud of gas and dust away, or are they going to? Is it going to collapse into other stars?
So you'll go through cycles. I mean, as for a while, as these stars go supernova, they'll trigger new star formation. But eventually, any of these clouds will dissipate due to radiation, pressure, and heat from these massive stars in them. And eventually, you end up with a star cluster that's just out by itself, and you don't see nebula around it anymore. So they kind of strip themselves away throughout their lives here.
So I've got a zinger question that has nothing to do with anything we've talked about tonight, and Pamela's going to love it. Which this comes from Brian Ross. And are there any telescopes searching for the hypothesized cosmic strings?
Oh yeah, people are always, it's not that you're so much getting competitive time on a given telescope to search somewhere specific for a cosmic string, but rather people look through existing images, they look through survey data, trying to find things that are consistent. And there's been several papers on things that should be followed up on, but there's never been a confirmed cosmic string. So there are people on the lookout for them, and you do see them popping up, not often, but you do see them on a rare but regular basis popping up in the literature with nothing confirmed, but people clearly looking.
But what is a cosmic string supposed to be?
Oh, how to explain that one in English?
The first person to
my
answer.
understanding, actually, I can jump in a little bit. I've been doing a little bit of back reading on that for preparation for the cosmology portion of the CosmoQuest class I'm teaching. My understanding that, and like I said, please correct me if I'm wrong, but my understanding is it's like akin to cracks in ice of the fabric of space.
Yeah, but explaining why they exist, I have to admit, it's math I could never possibly do, and I read the papers and go, wow, and feel dumb.
But
I don't know if you've had
something
better
to
luck
do
with
with
that.
like
No, I have not.
no one can explain it better. So there you go.
Maybe we should call up Lawrence Krauss.
We'll call Lawrence Krauss, and he'll tell us why they
He
come
might
from
be
nothing.
able to explain it, yeah.
Do you have him on speed dial?
No.
I interviewed him one time. Actually, it was great. He was a really neat guy to talk to.
I would think Kip Thorne or Sean Carroll might be better bets. But,
Sean
Did you
is the
shush
better
him,
barrel.
Pamela? I don't know if you shushed him.
No, I've never shushed Lawrence, just
I
me.
almost knocked him over at TAM this year, though. He's standing behind me, and I didn't see him. I almost
Really?
checked him to the ground, not on purpose. It was lunch. I was tired, and I'm a little taller than he is. I just didn't see him in my blind spot. It was kinda weird.
Just a little bit. Just a little bit, Scott.
Lawrence, if you're out there, we do love you.
We do love you.
We
Yeah.
tease with love.
I
Please
think
don't
that,
fail me, Dr. Krauss. Please don't fail me.
Lawrence Krauss's new book is kind of based on a talk that he was giving called "A Universe from Nothing," and it's one of the most interesting talks you can watch on YouTube. And I haven't read his book yet, but if it's based on the same thing, it's a
good.
wonderful just sort of video talk that he gives that explains how we can have a universe that kind of came from nothing, that if you balance out all the gravity and all the matter and all of the forces and the opposing forces, everything in the entire universe balances out to zero. So, and that's the only way that makes sense. So it's a really interesting talk. So do a search for A Universe from Nothing by Lawrence Krauss, and it's fascinating. Now, before we get to this object, Gary Ray asks, what is the furthest away object we can see tonight with the eyes and with simple binoculars? So what's the most distant object that we can see with just our plain old eyeballs?
If Andromeda's still up, then Andromeda.
Yeah.
Yeah, because I don't think there's any of the distant nebula that you can see even in a dark sky sight with the naked eye.
Yeah, globular clusters and dwarf spheroidals are the next furthest.
Right.
Well,
So, and even with binoculars, you're not going to get past. I mean, you might see some other galaxies that are a little further away than Andromeda, but that's still.
Yeah, M51.
Yeah.
But even the Great Globular Cluster in Hercules, M13, is still well within the Milky Way,
Yeah.
so you're still not even talking about the scales that Andromeda is at 2.5 million light years.
And once you locate Andromeda, once you learn how to find Andromeda, you can go out on some dark night, and if you've got pretty good dark skies, you can spot it as this hazy patch in the sky.
See, I plan on living for a couple billion years, so I'm waiting for it to come to me. I'm not going to look out.
That is the ultimate in lazy.
Yeah,
that's
that's
you know what? No, you come here.
What I was gonna say real quick is one of the things that a lot of people don't realize is that the actual size of Andromeda in the night sky is about 6 times the width of the full moon. It's huge.
Yeah.
But what you're seeing is that fuzzy little patch is actually the bright core of Andromeda. So, you know, if we could see all of it, it would actually resolve in a fairly large size object in the night sky. But because it's so distant and, you know, that light's spread out over such an area, what we wind up seeing is just that little tiny fuzzy patch.
So, Scott, when you're done with the virtual star party here, we'll just put you in a close orbit near a black hole, and because of time dilation, you won't have to wait quite as long according to your clock.
I'm totally down with that.
Yeah.
Can you put an infinite number of monkeys around me too? Because I want to read some Shakespeare while I'm at it.
Okay.
He's also tall, so he's
all
ready
right, so
to begin.
Gary, one last image here before we wrap up for tonight. What have we got? Gary?
Fraser always trying to move things along.
I'm moving it along, people.
Our great conductor.
This is called the Pelican Nebula, which is just below or
Right.
to the side of North America. Up here is the North American Nebula we were looking at, and this is the Pelican, which, since we looked at it a while back, I agree with Pamela. It looks more like a rabbit
Yeah.
with the nose here and the eyes and the ears coming out this way.
Or a pterodon, you know, some kind of winged dinosaur.
I'm all
Big
about
one.
the bunny rabbit on this
Or
one.
a shark face. I see like a shark face on the front.
I can get behind the shark face, but they don't usually have ears and fur.
And before anyone jumps in and starts asking what the Pelican Nebula is, I figured I'd kind of go ahead and steer us back in the direction and take Fraser's hint. Fraser, I'm going to mail you a conductor's hat. Is that okay?
Yeah. Would you? Yeah. What is that? What is this? But it's just more of the same nebula, right? As the California.
Yeah, it's an emission nebula. It's in that same region. So, you know, your typical emission nebula with a mix of star formation and gas clouds. So young, hot stars. You know, it's like Hollywood. Sorry, my daughter in the back, not wanting to go to bed.
Oh, is it
one day when she's old enough, I'll just put her out in the observatory and let her use the telescope. But,
exactly. Yeah, that'll be perfect.
But anyways, you know, as these nebula, you know, obviously with all the different stars and the different activity that's in them, causing them to dissipate over time, they'll obviously change as the component stars evolve and go through their life.
And there's an image. Scott's just put up a sort of a longer exposure image of it. It's fantastic.
What's amazing about these things is it's all transitory. As it orbits through our galaxy, it's getting compressed and stretched as they fall in and then orbit back out of the galactic arms. Stars are forming, supernovae are blowing bubbles, essentially. I mean, that's the thing about young stars, is they like to blow bubbles as they first give off their stellar winds, and then when they explode, you end up with further shock waves going on. And this is just what we see at this one moment in time, and 500,000 years from now, it could be completely different.
Very, very cool. Okay, well, I think we're sort of nearing that hour time, so why don't we start to wrap things up? So now we're going to be doing another show tomorrow. We're going to be doing some more astronomy casting, right, Pamela?
Yeah.
So have you picked a topic yet?
No.
No, you haven't? Okay.
No, I'll be doing that later.
Okay, I sent you a big list of topics, so you can pick one, and I can catch up with you. Well, Gary, thank you very much, and we're really glad again that you used your doomsday machine to control the weather for our benefit tonight, to be able to clear up those high clouds, and we we're sad for everybody else.
He
The
just
rest
gave
of the
Sean
team.
Connery a bunch of money. That's all.
Yeah.
Yeah, because
So
the
August to winter.
it was quite sad to hear astronomer after astronomer. Nope, cloud.
Yeah,
nope,
it
rain.
was
Nope,
really, there's this
clouds.
whole list.
Yeah, of everyone on the team getting
No.
rained out. But I mean, we're so used to this. I mean, we take cat herding to the next level with these virtual star parties. So,
Well, get some
and thanks
more
again
people.
to Pamela. Thank you so much for joining us, and Ray, thanks for bringing the baby, and Scott.
Yeah, thanks for having her.
Scott, thanks for joining us, and Thad, it was great. Oh, and Scott, there's one thing that I would like to mention, which was that you participated in a kind of historical event just a couple of days ago,
Yeah.
right? Do you want to explain what happened?
Yeah, one of our amazing astronomers, Peter Lake, out of Australia, did a remote control telescope to, I believe he's in New Mexico, and we observed the transit of an exoplanet from a star that's 550 light years away from us. So we did photometry data, and so you're able to actually see the magnitude go down, and we were able to curve it, and I had a little bit of a visual to go along with the dots and the plot on the graph. But we were literally able to see a planet go in front of a star 550 light years away from us. So the light was given away 550 years ago, and we're catching it now. It was just amazing, the technology that we have now. We're able to see planets that we didn't even know existed.
Well, and
years ago.
this is amazing on so many levels, because first of all, yes, wow, watching a planet orbit another star is kind of awesome. But beyond that, it was live, and as near as we can tell, it was the first time one has been streamed live while it was busy going in front. This was the Venus transit of an alien world.
Yeah.
Wow.
And then it was also captured by not a professional PhD having astronomer, but by an amateur working on a network of telescopes designed for amateur telescopes. So this was Peter Lake doing this as part of the iTelescope gang. And so
awesome.
it was the future is here.
Yeah, let's hear it for citizen science.
Absolutely.
amazing.
Okay.
And that was
All right, well,
it was just another leg of our December event, and we'll be continuing on with one tomorrow with Chad Haney doing a live MRI of a mouse heart.
Yeah.
On Tuesday, there's one with the NASA Dawn mission going over asteroid mappers and Vesta. So stay tuned for that this week, everyone, using the hashtag December, and we will continue even more, especially on that third week of December. Look for some awesome astronomy ones, especially with, the solstice coming up. Get a little choked up, all right?
Now, I mean, the goal here with all of the work that we're doing is we're trying to show people how science gets done live, and bring you right into the laboratories and right into the instruments, right into sort of the work that people are doing. And you can see, it's not, the pictures aren't as pretty necessarily as some of the stuff that comes after, but this is all sort of happening in real time, and you can really see the way the scientists work and the way the science gets done. And so if you're really interested in taking on science as a profession, or you just love science in general, this is a great way to connect you even closer to the research that's getting done, and that's really our big commitment. Now I'm Pamela, as people know, Pamela and I are going to be away for the next 2 weeks. We've got this Not the End of the World cruise that we're going to be joining with our respective families. I know it's going to be really brutal, and but Scott's going to be taking over and hosting while I'm gone.
That's right.
And he's got lots of practice. I trust him completely. But
He's
yeah, and if
unleashing
the
me
world
on-
doesn't end on December 21st,
And follow the two of us on Google Plus if you're not already, because I know at least I'll have international on my iPad, and the pictures will be going up.
perfect. Yeah.
Cool.
All right. So I won't see you guys for another couple of weeks. So thanks again, and I look forward to bringing this all back in the new year. But next week, Scott's going to be running the virtual star party.
That's right.
So, and don't forget to join the space community on Google Plus. All right. We'll see you all later. Thanks a lot.
Good night, everybody.
Good night.